This one, we're going to use that same identity, but we're going to go the other way. There's no way. By the way, this is the thing I really want you guys to leave the class knowing. When you're in calc next year and you see them multiplying sine and cosine together like this, they're probably using this double angle identity. It'll make the problem easier if you recognize it. So when I see these two things multiplied together and I'm supposed to do something with it, it's really helpful to keep this idea in mind, that 2 times the sine of theta times the cosine of theta equals sine of twice the theta. So in this case, because there's no way for me to get the one excuse me, trig function by itself, I just can't do it. What I can do is I really need a way to have just 2 sine of whatever, cosine of whatever. So I could rewrite this as if it was 2 times 2 sine x cosine x equals 1. Now let me just kind of like actually go off on a tangent for a second. I think it'll be helpful. Let's pretend instead it was like a 10 sine x cosine x. How could I use the double angle formula to help me rewrite this in terms of one trig function? What needs to be on this is the 2. The 2 needs to be there. I need to have this represented as something times 2 sine x cosine x, because this is the thing that I could turn into the sine of 2x. So usually when you're making this kind of conversion, or I don't know, conversion is not the right word, but whatever the word would be, manipulation, I guess, you need to figure out how can I change this and this so that I end up with something, that's equivalent but has a 2 sine cosine. I need a 2 sine cosine to turn it into this. And of course, at this point, you probably are thinking that would be a 5 there. Now that's not related to this problem specifically, but I just wanted to make sure that you understood what the heck just happened here. And I thought with all these 2's it was confusing, so I changed it to something else. So now that I have my 2 sine cosine, I can replace this with sine of twice that angle. So it's 2 times this equals this. And this is okay. We've solved problems like this. I have a trig function that I can isolate. To isolate it, I'd have to divide both sides by this 2 right here. So that means the sine of 2x equals a half. My trig function's isolated. I'm not worried about what's inside the parentheses just yet. I need to wait until I figured out angles whose sine is a half. So I'm going to definitely picture the unit circle in my head, and I'm picturing a short vertical component. So that's short side of a 30, 60, 90, and it's vertical. Likewise over here. These are 2 places where the sine would equal 1/2. And since they're the short side of the 30, 60, 90, it's that pi over 6 reference angle. So now 2x equals that pi over 6 plus a full rotation, or 2x could equal 5 pi over 6 plus a full rotation. So that means, and I'm so sorry for all the sloppiness here. Let's try and give myself some space to work. So if I take this guy, I have x equals pi over 12 plus a pi n. And that would give me x equals pi plus 12 pi n over 12. This fella gives me x equals 5 pi over 12 plus 12 pi n. So I'm going to end up with pi over 12, add 12 to the numerator, 13 pi over 12, 5 pi over 12, and 17 pi over 12. So if all this stuff in green is confusing to you, all that's review from stuff that we're working on, and we're still working on it, and we're going to have class time on Wednesday to work on it. But that's all review. The only part of this that was new was taking this thing, noticing that these were bumped together as a product, and now recognizing that when we see that, we're going to deploy the double angle formula. Let's try number 3 together and see how this is going.